Okay, this is part 2 of 2, talking about angles and how they relate to fractions, how they relate to angles, and especially when we're talking about inside of a circle. So I'm going to create another circle here. Let's see if I can make a better connection. A little better, maybe. So one of the problems on your practice exercise is going to talk about, they show you an angle and they're going to, try to get to the center here. So they might show you an angle, and without a protractor, it's hard to measure how much that angle is. You can kind of take a guess. You know how much a 90-degree angle is. You should know by now that if it's a straight line, such as this, we would make this our vertex. The opening from here to here, that's 180 degrees. So there's some angles that you should be able to recognize without actually having to measure. One of the most common ones is the right angle, which is always going to be 90 degrees. Even if they don't give you the little square corner in there, you should know when you see something that looks like where, let's say, a building is meeting a sidewalk, unless we're talking about an earthquake or something like that, that's going to be 90 degrees, okay? But when we talk about something like this, this angle here, it's a little bit harder to get an accurate guess. We have to keep in mind that this entire circle all the way around, remember in the first video I showed you just what 1 degree would look like, is how much? How much is it to go all the way around the circle? How many degrees are inside this circle? Well, every circle all the way around from this point, if I had a bunch of smaller angles, is always going to be 360 degrees. And that's really important to remember, because with that, if I keep this in mind, this is really important to remember, because you're going to use this information to help you figure out how much the opening is from this line here to this line here. So they might ask you, well, how big is this angle? What's the measurement in degrees of that angle? And what they'll often do is they'll just give you a fraction. They'll say that this angle right here is worth 1/6 of the entire circle. Well, 1/6 of 360. What is that? What is 1/6 of 360? So jogging our memory, going back in time a little bit, when we were in the multiplication unit that dealt with fractions, you can remember that Mr. Wiles will hopefully remember that there was a really easy way to solve questions like that. They said, you know, how much is 1/6 of, let's say, 360? Well, whenever you see of, what is 1/6 of? And we can just think of that as like a multiplication problem. Okay, that of can be replaced with a multiplication sign. So if you're asked what is 1/6 of 360, 1/6 times 360. Well, 360 is the same as 360 over 1. Any number, if you want to turn it into a fraction, you can just put it over 1. So we're making 360 our numerator, just put a 1 as a denominator, and then we just multiply across. So if I take this 1, I multiply with the other numerator there, 1 times 360, that's going to give me 360. And then 6 times 1, multiplying my denominators across the bottom, just take this 6, multiply straight across with the 1, and 6 times 1, well, that's 6. So now I have this fraction here, 360 over 6. Hopefully you can remember that Mr. Wiles also said that a fraction is like a division problem. So if I were to make my house right there to divide, you want to get it right, put the top number to the right. 360 is on top, so that's what goes on the right side. Remember, you want to get it right, put the top number to the right. And then 6 is going to be on the outside, okay? Here's my dividend, here's my divisor, and now it's time to divide. When I get my answer, my quotient here, this is what that angle is going to be worth. It was 1/6. It was only 1/6 of the 360. Remember, 360 was your entire circle. And then they told you in the problem, hey, this is 1/6 of 360. So that's why we multiplied that. And I'm looking at this division problem. It's not that hard. It's a basic math fact. I know from my knowledge that 6 times 6, in fact, equals 36. But I'm still going to do the long division just to show you. 6 will not go into 3. I can extend, instead of just looking at the 3, now I can look at the 36. But I'm going to even go, I'm going to go the long route, okay? The next step here is to multiply. 0 times 6 is 0. Next step is subtract. So this would be 3. Next step is bring down. And that's why sometimes when I'm doing division, if it doesn't go into the first number, I just extend to the second number because look, there it is right there, 36. So it just kind of takes a step away, making it a little bit faster to solve this. But anyway, continuing with this problem, 6 goes into 36. We know the basic fact. It's right up there. It goes in 6 times. And then your next step is multiply. 6 times 6 is 36, which we write underneath. What's the next step? If you said subtract, then you are correct. 36 minus 36 would give me 0. Still have a 0 that I need to bring down here. Will 6 go into 0? No, it will not. And I can let you know that it will not by putting a 0 up here. 0 times 6 is 0. When I subtract, I'm not going to have a remainder. So, going back to the problem, 1/6 of 360, well, there it is. I figured it out. That equals 60. What that means is that this 1/6 of the total 360 is going to equal 60. It's actually 60 degrees though. All right. So you can watch this video as many times as you need. I'm going to give one more example, but not in this video because this one's kind of long. All right. Hopefully that made sense. Again, you're allowed to, review this video as many times as you need to. All right.